हेलो माय डियर स्टूडेंट्स। तो कैसे हैं आप सभी? आशा करता हूं आप सभी अच्छे होंगे और अच्छे से सीयूईटी की तैयारी में जुटे हुए होंगे। और आज हम पढ़ने वाले हैं द सॉलिड स्टेट, द मोस्ट इंपोर्टेंट चैप्टर ऑफ योर सिलेबस, जो कि आपने अपने लास्ट ईयर सिलेबस के अंदर पढ़ा ही नहीं है। इसके बारे में सोचा भी नहीं कि ये सिलेबस या ये चैप्टर भी आपसे पूछा जा सकता है, क्योंकि अब तक जो सिलेबस आपने पढ़ा है उसके अंदर इस चैप्टर के बारे में जिक्र नहीं था। कुछ कोविड के बाद से इस चैप्टर को हमारे सीबीएसई सिलेबस से हटा दिया गया था, लेकिन हमें सीयूईटी में ये सिलेबस पूछा जाएगा। तो अगर ये पूछा जाता है तो ये चीज याद रखें कि पहली बार में ही आप इसे कुछ इस तरीके से याद करें, लर्न करें, रिवाइज करें कि आपको इस पे बेस्ड जो भी क्वेश्चन आए उनको एक्यूरेसी के साथ में सोल्व कर पाए। तो अब यहां हम शुरू करते हैं सॉलिड स्टेट से। तो फर्स्ट ऑफ ऑल सॉलिड स्टेट में हम चलते हैं जनरल कैरेक्टरिस्टिक्स ऑफ सॉलिड्स। आई मीन मैं कह दूं कि भी कुछ जनरल प्रॉपर्टी जो सॉलिड की जो हमें पढ़नी है उनके बारे में जिक्र करते हैं। सॉलिड्स हैव डेफिनेट शेप एंड डेफिनेट वॉल्यूम एंड डेफिनेट मास। देन सॉलिड्स have definite mass, definite volume and definite shape. Intermolecular distance are too short or negligible. The particles distance, the interparticle distance between solids is very short, or we can say it is negligible. Intermolecular forces will be strong. एक सॉलिड के बीच में जो पार्टिकल्स के बीच जो फोर्स ऑफ अट्रैक्शन होता है वो स्ट्रॉन्ग फोर्सेस ऑफ अट्रैक्शन होता है। Constituent particles have fixed positions, means कि these particles have fixed positions, they cannot move from this to this side, from this to this side, or up and down. ये constituent particles अपनी जगह पे फिक्स होते हैं, ये मूव नहीं कर सकते हैं। They can only oscillate on their, they can only oscillate about their मीन पोजीशन। सिर्फ ये वाइब्रेट कर सकते हैं ऊपर नीचे और साइड में, लेकिन ये मूव नहीं कर सकते हैं। खैर नेक्स्ट, इनकंप्रेसिबल और रिजिड। सॉलिड्स जो होते हैं वो इनकंप्रेसिबल होते हैं, आप इनको प्रेस नहीं कर सकते, और ये रिजिड स्ट्रक्चर्स प्रोवाइड करते हैं। खैर वी कैन मूव ऑन आवर नेक्स्ट स्लाइड। सॉलिड्स कैन बी क्लासिफाइड इनटू टू टाइप्स। आई मीन क्लासिफिकेशन ऑफ सॉलिड्स। अब जब भी हम किसी चीज का क्लासिफिकेशन करते हैं तो ये बेस मानकर चलते हैं अलग अलग चीजों पे। तो क्लासिफिकेशन इन दो सॉलिड्स का जो क्लासिफिकेशन करते हैं वो अलग अलग तरीके से करेंगे। तो फर्स्ट ऑफ ऑल क्लासिफिकेशन ऑन द बेसिस ऑफ अरेंजमेंट ऑफ कॉन्स्टिट्यूएंट पार्टिकल्स, कि आप किस तरीके से पार्टिकल्स को अरेंज करते हो उनके ऊपर बेस्ड हम क्या करते हैं, क्लासिफिकेशन पढ़ते हैं। फर्स्ट ऑफ ऑल there are two types of solids. First one is crystalline solids and the second one is amorphous solids. So we can say that classification on the basis of types or arrangement of constituent particles, there are two types of solid. First is crystalline solid and the second one is amorphous solids. Next, first of all we can define the crystalline solid. What are crystalline solids? These are the type of solids in which constituent particles are regularly arranged or have a geometrical arrangement. Crystalline solids are those type of solids which have regular arrangement of constituent particles, which have regular arrangement of constituent particles, or geometrical arrangement, or geometrical arrangement of constituent particles. Second one is amorphous solids. Amorphous solids are the type of solids which have irregular arrangement of constituent particles or random arrangement of constituent particles. Here you can easily show that the particles are randomly arranged. So the type of solid is amorphous solid. Particles of solid are randomly arranged or irregular arrangement are called amorphous solids. There are two types of solid. First one is crystalline solid and the second one is amorphous solid. Crystalline solids are the type of solids which have regular arrangement of constituent particles, and amorphous solids which have random or non-geometrical arrangement of constituent particles. So now we can move on our next slide. The difference between crystalline solid and amorphous solid. Difference between crystalline solids and amorphous solid. First of all, crystalline solids have a geometrical shape, और हम ये कह सकते हैं definite geometrical shape. They do not have definite geometrical shape. Crystalline solids are long range order solids. Amorphous solids are short range order solids. Crystalline solids have sharp melting point and boiling point. They have no sharp melting point and boiling point, or amorphous solids are heat over the range of temperature. Clear? Next, on cutting, crystalline solids give a clean cleavage or a regular cleavage. On cutting the crystalline solids, they can give regular cleavage or a clean cleavage or a geometrical cleavage. Next one is amorphous solids does not give a clean cleavage, they give a irregular cleavage. They have definite heat of fusion. They have definite heat of fusion, but amorphous solids do not have definite heat of fusion. Next one is these are anisotropic in nature. This is the property anisotropy or isotropy. We can learn about this on next slide. They are isotropic in nature. Amorphous solids are isotropic and crystalline solids are anisotropic in nature. Examples of crystalline solids: sodium chloride, NaCl, diamond, quartz, calcite, sugar, mica, etc. And the examples of amorphous solid: rubber, glass, plastic, cement, and paraffin, wax, etc. etc. Now we can learn about anisotropy or isotropy on our next slide. So we can move on our next slide. First of all, anisotropy. Now here the arrangement of constituent particles is regular. So this is an example of an crystalline solid. So this is an example of an crystalline solid. Now we can select the two sides of the solid. Now we can select the two sides of solid to understand an isotropy property. First side, from this to this, from A to from B, and the second one is from this to this. Here C point, here D point. So you can see in our diagram, from point A to B, the particles has a regular arrangement. Same type of particles are present here. Same type of particles are present here. But on moving from C to point D, you can easily see first particle, then second a different particle, then similar as first particle, then different particle. So the different arrangement in different directions, different arrangement in different directions in a crystalline solid. So this property is known as anisotropy. The physical properties like electrical resistance, refractive index, and show different values when measured along the different directions in same crystals is called anisotropy. It is due to anisotropy. The arrangement of particles differ in different directions is called anisotropy. These are called anisotropic solids. Anisotropic solids. When arrangement of particles is different in different directions, then the property is known as anisotropy. So now I think you can easily understand about anisotropy. Now we can move our next slide to learn about isotropy property. So isotropy. So we can move on a isotropy. Here the arrangement of constituent particles is random. So there is no regular arrangement from this to this, and there is no regular arrangement from this to this. This side have irregular arrangement. This side also have irregular arrangement. So the same type of arrangement of constituent particles. So the physical properties like refractive index or etc. etc. have same values in all directions. So amorphous solids are isotropic in nature. The values of any physical property would be same along any direction is called isotropy. No long range order, and the arrangement is irregular along the all directions is isotropy in nature. So now we can move on our next slide. Pseudo solids or super cooled liquid. You usually see that a plastic pen or a plastic bottle, when we heat this, it will be converted into liquid. So we can say that the plastic bottle is pseudo solid. Some of the examples is like chair is a pseudo solids. So now amorphous solids have tendency to flow very slowly, are called pseudo solids or super cooled liquids. Therefore, they are called pseudo solids or super cooled liquids. Some of examples is like as glass. Some of solids which can flow very slowly are called pseudo solids or super cooled liquid. Now, on our next slide, note number first, glass objects from ancient civilizations, from ancient times. Glass objects are like as milky in appearance due to crystallization. Due to crystallization, ancient times, the glass objects are milky in appearance. And the second one is glass is an amorphous solid. So because particles of glass can move very slowly, so we can say that glass is an amorphous solid. On heating, glass become crystalline. On heating, glass become crystalline at some temperature. Some of the temperature or some of the point of temperature, a glass can be crystalline. But when the temperature will be changes, the particles can move from one position to another position. So we can say that glass is an example of pseudo solid or super cooled liquid. Now, glass panes fixed to windows, doors, old buildings are found to be slightly thicker at the bottom than at the top. You can easily observe some of glass windows are little bit thicker from downside or from bottom due to flow of constituent particles from top to bottom. The next, glass flows down very slowly and makes the bottom portion as slightly thicker. I have already said about this. Next we move on our next slide. Classification of crystalline solids. Firstly, we learn about the solids are of two types on arrangement of constituent particles. There are two types. First is crystalline solid and the second one is amorphous solid. Crystalline solids have regular arrangement of constituent particles and amorphous solids have irregular arrangement of constituent particles. Now, we can classify the type of crystalline solids on the basis of type of particles present in the solid. Classification of crystalline solids on the basis of particles present in the crystalline solid. Type of particles present in the crystalline solid. So now classification is based on the intermolecular forces, or crystalline solids are classified into four types. First one is molecular solid. Second one is ionic solids. Third one is metallic solid. And the fourth one is covalent solids. Fourth one is covalent solids. Molecular solids are those type of solids whose constituent particles are molecules. Molecular solids are those type of solids whose constituent particles are molecules, whereas ionic solids are those type of solids whose constituent particles are ions. They have strong electrostatic force of attraction between them. But molecular solids have two types of force of attraction, London dispersive forces of attraction, like as hydrogen bond, etc., etc. Third one is metallic solids. These are the type of solids whose constituent particles are metal ions or metals. Covalent solids, whose the force of attraction between the constituent particles is a covalent bond. Simply, we can say that covalent bonded particles are found in covalent solids. Now, we study about it one by one. First of all is molecular solids. In the molecular solids, molecules are the constituent particles. I have already said about that. Molecular solids have molecules in them. Second one is molecular solids are classified into three types more. First of all, solids are of two types. Crystalline solid, amorphous solid. Then crystalline solids are of four types. Molecular solids, ionic solids, metallic solids or covalent solids. Now, molecular solids are of three types. There are subtypes of solids. First one is non-polar molecular solid. Second one is polar molecular solids. And third one is hydrogen bonded molecular solids. All of them studied up in this one by one. So we can move on our next slide. First is non-polar molecular solids. The type of solids in which atoms or molecules are held together by dispersion forces or London forces. Molecules are held together by dispersion force or London force. These are soft due to weak attraction present in between the molecule. And non-conductor of electricity because these have no transfer of electrons, or they generally has a covalent bond between them, or we can say that weak forces of attraction between them. They have low melting point or boiling point due to their soft structures. They have low melting point and boiling point due to soft structures. These exist in liquid or gaseous state at room temperature and pressure. These solids are freezed. These liquids are freezed to make into solid state, like as hydrogen, chlorine, iodine, etc. Now we can study about polar molecular solids. Here, constituent atoms have slight difference between their electronegativity. So the poles of partial positive and partial negative charge will generated. So we can say that polar molecular solid. These are the type of solids whose constituent particles are bonded together or held together by dipole interaction. They are also soft and non-conductor of electricity. Their melting point and boiling point are slightly higher than non-polar molecular solids. Example, solid sulfur dioxide and solid ammonia. Next, and the third type of solids are hydrogen bonded molecular solids. These are the type of molecular solids whose constituent particles are bonded together with hydrogen bond. So we can say that the molecules are held together by hydrogen bond. And this is a strong bond as compared to London dispersion forces or dipole interactions. They are non-conductor of electricity because only ionic conductor or metallic conductors can conduct electricity due to the flow of electrons or transfer of electron, etc., etc. So they are generally volatile liquids. These are generally volatile liquids or soft solids. These are generally liquid or soft solids under at a room temperature. Example, H2O. Here H2O will be converted into solid form when we freeze it. Now we can move over next slide and the next type of solid, ionic solids. I have already discussed about that. Ionic solids whose constituent particles are purely ions, positive or negative ions. Ions are the constituent particles and formed by the three-dimensional arrangement by cations and anions bound by a strong electrostatic force. These are the solids have hard and brittle in nature. They have high melting point and boiling point due to strong forces of attraction between them. Now they are insulators in solids. They do not conduct electricity in solid form, but their molten state or in aqueous solution they can also conduct electricity. These are good conductor of electricity. Ionic solids are completed. Then some examples, for example, NaCl. For example, NaCl. Next, the next type of solids are metallic solids. Metallic solid consists of positive ions or positive metal ions. इन अ सी ऑफ मोबाइल इलेक्ट्रॉन्स, बहुत सारे इलेक्ट्रॉन्स के बीच में क्या होगा, पॉजिटिव आयंस प्रेजेंट. These are held together by strong electrostatic force, or these are held together by metallic bond also. They are malleable and ductile. We can already studied about them in 9th 10th classes. Key solids are good conductor of electricity and heat and electricity, etc. They are malleable and ductile. They can easily converted into wires or thin sheets. Good conductor of heat and electricity also. Now, covalent solid. This type of solids, the last type of solids, and the particles are bonded together with covalent. The atoms are held together by strong covalent bonds. They are very hard and brittle. They are very hard and brittle. They are very hard and brittle, and these are insulators because they cannot conduct electricity. Some examples are in between the covalent or network solids are graphite. They can also a good conductor of electricity. Diamond and silicon carbide, etc. are the example of covalent or network solid. Next one, graphite. I have tell about this in last slide before 5 or 10 seconds. Graphite, it's soft and conductor of electricity due to free electrons. In the structure of graphite, every carbon atom has a one free electron. Due to this free electron, graphite is a very good conductor of electricity. The free electrons make a graphite a good conductor of electricity. Graphite is a soft solid and a good solid lubricant. It is also used as engine oils because different layers can slide one over other. The layers of graphite can move or can flow from one to another. The next नोट नंबर नेक्स्ट खत्म आपके बाद. अब बात करते हैं क्रिस्टल लैटिस की. व्हाट डू यू मीन बाय अ क्रिस्टल लैटिस? A regular three-dimensional arrangement of points space is called crystal lattice. There are regular three-dimensional arrangement of points in a lattice is called crystal lattice. You can easily see in this image. Crystal lattice. Now, next one is characteristics of a crystal lattice. Each point in a lattice is called lattice point. Each point of crystal lattice is called a lattice point. Lattice site represent one constituent particle. Lattice site represent one constituent particles present at. Now, the constituent particles may be atoms or molecules and also ions. Lattice points are joined together by straight lines which give a geometry of lattices. These lattice points are joined together to obtain or to write the structure or to draw the structure of crystal lattice. Then we can move on our next slide, the unit cell. It is the basic unit of a solid. Unit cell is the smallest repeating unit of a crystal lattice, which when repeated different directions generates the entire crystal, which can make an entire solid. When we repeat unit cells again and again, a crystal lattice is formed. An entire crystal lattice is formed as unit cell. There are two types of unit cells. First is primitive unit cells and second one is non-primitive unit cells. Primitive unit cells are the type of unit cells in which constituent particles are present only and only at the corners of the unit shell. Non-primitive unit cells are the type, or we can also say face-centered unit cells. We can also say centered unit cells or body-centered unit cells also. Body-centered, the type of unit cells. We can discuss about the type of unit cells. First of all, characteristics of a unit cell. The dimensions are along the three edges A, B and C. The structure of a unit cell, we can discuss about the structure of a unit cell is like that. A cubical structure. This is the structure of a unit shell. The constituent particles are present at the corners of the unit shell and also on the faces of cube like this. So the dimensions are along the edges A, B and C. Dimensions are along A, B and C. And the edges may not be mutually perpendicular to each other. These edges may or may not be mutually perpendicular to each other. Angles between them as alpha, beta or gamma. Angles between them as alpha, beta and gamma. So a unit shell is characterized by 6 parameters: edges A, B, C and angles alpha, beta or gamma. These 6 parameters are from different type of unit cells or crystal lattice. Now discuss about the type of unit cells. First of all, primitive unit cells or centered unit cells will second type of unit cells. Now first of all, primitive unit cells. The constituent particles are present only at the corners of the unit shell is called primitive unit shell. First of all, corners, 8 corners has this cube has 8 corners, so this unit shell has 8 corners and constituent particles are present at the corners only. The type of unit shell is also known as primitive unit shell. We can move on our next slide, face centered or centered unit cell. Centered unit cells are of 3 different types. First type is face centered unit cell, FCC. Second is body centered unit cell, BCC. Third one is edge centered unit shell, edge centered unit shell. There are 3 types of different unit cells. First is face centered unit cell, second one is body centered unit cell and third one is edge centered or end centered unit shell. Now we can discuss about them all. First one is body centered cubic unit shell. The constituent particles are present at the corners as well as center of the cubic unit shell is called body centered cubic unit shell. You can observe in the structure the constituent particles are present at the corners as well as in the center of the cubic unit shell. So we can say that this type of unit shell is known as body centered cubic unit shell. Now we can move on our next slide to discuss about next type of unit shell as face centered cubic unit shell. Now we can say that the type of unit shell in which constituent particles are present at corners as well as all the center of faces of this cube. So now this is the cubic face centered cubic unit shell. The particles are present at the faces of the cubic unit shell and also present at the corners of the cubic unit shell. So this type is face centered cubic unit shell. Now on our next slide we discuss about end centered cubic unit shell. The constituent particles are present at 2 opposite ends, not at all opposite ends, 2 opposite ends as well as corners of the cubic unit shell. Now these are the particles which are present at the corners and these are the particles which are present at the 2 opposite ends of the cubic unit shell. So these are the type of unit cells. Now in next lecture we discussed about packing of solids and the type of solids, type of unit cells which form different type of lattices. I hope you understand easily this complete lecture. Now we move on our next slide but in next lecture. So thank you so much and bye bye.